Hi dear students, here a question from GATE 2021 related to CSE department which is coming from linear algebra. Let us quickly enter into the question. So which is came in the Set-1, that means in the morning session. The question is, consider the following matrix. Okay, this 4x4 matrix, so it is a 4x4 matrix. The largest eigenvalue of this above matrix is, so since it is a 4x4 matrix, total 4 eigenvalues exist: lambda 1, lambda 2, lambda 3, lambda 4. Total 4 eigenvalues exist because it is a 4x4 matrix. So fourth degree characteristic equation you will get. If you solve it, you will get 4 eigenvalues. In these 4 eigenvalues, which one is the largest one? So that is a question mark. See, there is no particular formula to find directly what is the largest eigenvalue. Compulsory we need to find all the eigenvalues from the characteristic equation. In that we have to look at what is the largest eigenvalue. Since it is a 4x4, we need to attack this problem carefully. Look at step by step. Solution. So eigenvalues can be obtained by the characteristic equation, you know already, which is a minus lambda I, modulus of a minus lambda I is equal to 0. How to get it? Look at, so it's not modulus, it is determinant of a minus lambda I is equal to 0. Okay, so now what is a? A is this given matrix 4x4 matrix. Let us substitute here minus lambda into I, identity matrix. Since A is a 4x4 matrix, so identity matrix should be of 4x4 matrix. So this is also 4x4 matrix. So determinant of A minus lambda I is equal to 0. So let us simplify this. What will you get? So subtract this matrix from this matrix. So what will you get? 0 minus lambda into 1. So minus lambda here, and this 1 minus 0. So 1 only. So all these entries are 1s only, except a11. So a11 become minus lambda. Similarly, a21 is 1 only, but a22 is minus lambda, because 0 minus lambda is minus lambda, and these are 1s only. Similarly, only diagonal entries becomes minus lambdas. Look at, so this you will get. So therefore determinant of this matrix we need to find out in the next step. But since it is a 4x4 matrix, so determinant is too difficult. Actually, how to proceed the determinant for this kind of 2x2 matrix? Since it is a 4x4, so we need, generally we need to proceed like this. So minus lambda into, right? What we need to do? So this submatrix we have to take. So this submatrix we have to take. Okay, so this submatrix. So this determinant you have to write here. You know how to find determinant of 3x3 matrix. Okay. Next, this entry. Okay. So next, from this entry, so with respect to 1 we have to expand. So and one entry is nothing but at first row and second column, right? So plus minus 1 whole to the power of first row second column, like this. Here it is actually minus 1 whole to the power of first row first column. That's why it is plus 1. Okay, minus lambda into this. So next one. So with respect to 1 we are expanding. So into 1. With respect to this 1, so this column and this particular row we have to remove. So what you got? The remaining 3x3 matrix. So this is the remaining 3x3 matrix. So this determinant you have to write here. Similarly, plus next to minus 1 whole to the power of for this it's first row and third column entry. First row, third column entry. So we will get plus only. So 1 into, again same story. Which is determinant? Again the particular row and column you have to remove. So which one? So this particular column and this particular row you have to remove, and remaining, so this 3x3 order, right? So this 3x3 determinant you have to write here. Similarly, plus last one minus 1 whole to the power of, so this one is first row fourth column entry. So first row fourth column entry, therefore minus you will get. So into 1, what will you get here? Again same story. So with respect to this one you have to expand, this one you have to expand. So this corresponding column, corresponding row you have to remove. So this 3x3 matrix are determinant you need to compute, and that determinant you have to write here. So in general you have to compute like this. So it becomes too lengthy because inside the coefficient matrix is the sub matrix is 3x3 matrix. Again finding somewhat difficult. So indirectly 4 determinants we need to calculate. 4 3x3 matrices. 1, 2, 3, 4. So in order to proceed like this, or to save the time, so within the time we have to proceed the calculation. So what I am doing look at, I want to modify the first column as C1 plus C2 plus C3 plus C4. So if I modify the columns, determinant cannot change. You look at the properties of determinant, and again same story for the row operations also, determinant does not change. But if you interchange the rows, determinant will be changed. Okay, but if you do like this kind of operations, determinant will not change. So therefore what I am doing now, in C1 I'm adding all the columns. So therefore minus lambda plus 1 plus 1 plus 1, what will you get? Minus lambda plus 3. So in first column. Similarly here 1 minus lambda plus 1 plus 1, what will you get? Minus lambda plus 3, like that. So similarly minus lambda plus 3, minus lambda plus 3, and these entries are same as it is. So second column is not modifying, third column is not modifying, fourth column is not modifying. So as it is I have written second column, third column, and fourth column as it is I have written. So in the next step, look at first column, minus lambda plus 3 is common. So then I can take minus lambda plus 3. So this step is suitable provided if first column having the same entries. For example, instead of having minus lambda plus 3, for example, you are having this kind of entries, minus lambda plus 2 first entry, and minus lambda plus 1, and minus lambda plus 5, and minus lambda plus 2. For example, this kind of entries you are having in the first column, then this method is not suitable. This method is not suitable. Definitely you should have the same entry in the first column. Then in the next step what I will do is I will take common like this. Look at, so minus lambda plus 3 is out from the first column, therefore what are the common? 1 1 1 1, all are ones. So remaining entries are same, does not change. So second column, third column, fourth column entries does not change. Okay, and which is equal to 0, determinant of this equal to 0. In the next step what I am doing is make these 3 zeros. If you make these 3 zeros, then this expansion of this determinant become easy. Just now I expanded this determinant, so no need to expand through this one, and this one. If you make these 3 are zeros. Okay, I will explain that. You look at, now look at what I am doing is R2 is modifying as R2 minus R1, so that this entry becomes 0, and third column, third row first entry, how it becomes 0? R3 minus R1. Look at R3 minus R1. Next similarly fourth row R4 minus R1, so that this entry becomes 0. So okay, all first column entries I want 0 except the first entry. Now look at, so look at, you are getting like this. Okay, so here R2 is R2 minus R1, therefore 1 minus 1 0. Next minus lambda minus 1, so here this is 8 2 2, second row second entry. Similarly 1 minus 1 0 and 1 minus 1 0. Similarly third row and fourth row. Done. Now look at, you expand through 1. Now what happens? So same, so look at here what I explained just now. Here minus 1 whole to the power of 1 plus 1, so 1 into, let me write here, so minus 1 whole to the power of 1 plus 1, right, first row first column into 1. Now so this submatrix, determinant I want, so minus lambda minus 1 into, okay, whatever, that determinant I will find out. Next one, look at this one, so minus 1 whole to the power of 1 plus 2, first row second column entry, okay, into expansion through this one, then what you will get? So which submatrix you will get? So through this, therefore these two you have to remove. What you have to do? 1 into, which determinant I need to compute? Look at here, so this determinant I need to compute, but look at what is the determinant of this? Indirectly it is 0. Look at first row completely zeros, therefore it is 0. So no need to go for expansion of the second entry with respect to second entry. Similarly, come to this one, come to this entry, so minus 1 whole to the power of first row third column entry, into 1, right? So 1 into the corresponding submatrix is, so the corresponding submatrix is this. Okay, so this is the corresponding submatrix. Now in this submatrix again look at, the middle row is completely 0, therefore this is 0. Similarly fourth one, minus 1 whole to the power of first row fourth column entry, right, fourth column entry. Then what you will get? Look at now here, so this will be, yeah, so with respect to this I want, with respect to this, so therefore this corresponding column, this corresponding row you have to remove. Look at, in this third row completely 0, isn't it? So this submatrix, 3 by 3 submatrix determinant I want. So in this third column is, third row is completely 0, therefore determinant is obviously 0 you will get. So therefore indirectly look at, the last 3 becomes 0, no need to expand. We need to focus on only expansion through first entry, that means expansion through this one only. It is because of we made these three are zeros, these three are zeros. Because of that we got this kind of simple conclusion. So that's why what we are doing is we are proceeding this column operation. C1 is modifying as C1 plus C2 plus C3 plus C4. If you do this column operation, determinant will not change. Okay. So therefore, yeah, let us proceed to the next step. Here, let me proceed. Next step, let us expand that determinant. So minus lambda plus 3 into expansion through this one I am doing. So 1 into let us come to this inner 3 by 3 matrix. So here what I will get is, yeah, let us come to this 3 by 3 matrix. So this 3 by 3 matrix, what you will get? So look at it. So minus lambda minus 1 into over and AD minus BC. So minus lambda minus 1 into minus lambda minus 1 minus 0 minus 0. 0 into 0 is 0. So 0 into 0 is 0. 0 into 0 is 0. Okay. I no need to proceed for this with respect to 0 and with respect to this 0 because they are already 0. So 0 into something is 0, 0 into something is 0. That's why it is gone. So next with respect to these 3 is not required. Just now I shown you. Right? So therefore, let us proceed to the next step. So this is a final determinant. Let us simplify this. So minus lambda plus 3. So minus lambda minus 1, minus lambda minus 1, minus lambda minus 1 is equal to 0. So if you take minus from all the brackets, from the first bracket minus common, second bracket minus common, fourth bracket 1 minus common, third bracket also 1 minus common. Overall 4 minus will comes out, that is plus. So lambda minus 3, lambda plus 1, lambda plus 1, lambda plus 1. So indirectly how many eigenvalues? The eigenvalues are total 4. First one is 3, second one is minus 1, third one is minus 1, fourth one is minus 1. So these are the eigenvalues. 3, minus 1, minus 1, minus 1. So therefore finally the largest eigenvalue is how much? So therefore the largest eigenvalue is 3. Okay. So this is the largest eigenvalue, which is, so look at, so in this the largest eigenvalue is 3. Okay.